Hey there, I'm Alan Furstenberg.
And I'm Mark Tucker. Welcome to Two Voice Devs.
Two Voice Devs. How's it going, Mark?
It's going well. It's busy. Some of my projects at work are pushing off to the deployment, certification, publish stage,
Oh
and
man, it's
it's
so good when
good.
that finally happens.
It does. It's there's always those last minute kind of like, oh. Sometimes the client's like, "Oh, can we get these features in?" And you're like, kind of late for that, maybe." Or, "Sure, these ones we can. Let's hit the other ones in the maintenance cycle." Or, and other ones, there's just always some unforeseeable things, but
There's
it's
always
always a good feeling.
there's always something, and even once it's in production and it's out there and it's deployed and it's being used, it's not like that's the end.
No, not done.
But it's a wonderful, wonderful milestone. So I know you're not quite there yet, but congratulations on
Yes, I'm
almost getting
definitely
there.
feeling it's close. Yeah. Thanks. Things
Uh,
going okay for you?
Busy. It's busy. It's we're finally getting into September, and the end
September.
of the quarter is coming up. So some clients who like having things done by the end of quarter
Yep.
want their things done by the end of quarter. So we're coming up on that real soon. So things are busy. Yeah. I was thinking, last week we talked about the text to speech part of the whole conversation cycle, and the
Right.
various technologies that let us do that, and so forth and so on. And I'm wondering if what do you think about this week? Let's tackle it from the other side. The speech to text part, or the speech to intent part. How stuff
Sure.
gets into the voice cycle. What do you think?
Yeah, that sounds good.
Okay.
So we'll talk about a few terms. I think like ASR is probably something we want to make sure we bring up.
Yep.
NLU and something called SLU.
SLU. Okay.
So
That's a new term to me, but we'll get to it, I think.
yeah,
Uh,
why don't you go ahead and tell us a little bit about what some of those terms mean?
so the big two parts in this are ASR, or automatic speech recognition, and NLU, natural language understanding. And I sometimes see this called NLP, or natural language processing.
Right.
And honestly, I'm sure there are people that would tell me there is a difference between NLP and NLU. I'm not sure I know what the difference is, but I'm sure there's somebody who will tell me what the difference is. I
Well,
don't know. What's your take on the difference between the two? They're
I don't know personally. I don't know. I always kind of thought NLP is kind of like a broader category of things,
okay.
and NLU being one of the things that are in that. From a developer's perspective, we're consumers of services that provide ASR and NLU. We're not the type of developers that are actually making the NLU and
Right.
ASR
No,
stuff, and so I'm sure that there's a different perspective if you're a developer that's focusing on that part.
no, that's a good point. And I'm sure at some point we'll get guests in who will talk about the details that go into building an ASR model, building that language model, the language processing model, and building the NLU, not just using an NLU, but that's
Right.
not going to be tonight.
Yeah. Because
So
yeah, go
go ahead.
ahead.
Yeah.
I was just talking about that we're either starting with an audio file, or like in essence recording from a microphone of spoken text as input, or we have the text transcription. So um, it's kind of like ASR sits in front of NLU a lot of the time.
Yeah.
But there are some, like if you were doing a chat bot where you were typing, or something with SMS where you're texting things back and forth, then
You're
then you'll
avoiding the
skip.
ASR. Yeah.
Yeah, you're skipping the ASR part, and you're going right to the NLU because you're trying to figure out, well, here's this sentence, that the string of words, this text, this big string, that have space tokens in it.
Right.
Um, what does this thing even mean, or how does this bot or assistant interpret that thing? And
Right.
that's the NLU part.
And I'd also say that there are times that you really don't need the NLU part. If you're just looking for sentiment analysis, for example, is this a
Mhm.
positive statement or a negative statement? Then all you really need is the ASR part
Right.
to feed into the sentiment analysis, to feed into the parts of speech analysis. So there are other components that can be at play. And some of the services offer these components either bundled into something like ASR or as separate components.
Yeah, and then I'll talk about this last term that, and just throw that out since we're kind of defining things right now, is this SLU, which I actually heard this term quite a bit when doing stuff with Jovo. They call it spoken language understanding. It's kind of the merging together of ASR and NLU.
Oh, interesting.
Where sometimes you can skip the actual text part in the middle. You start with the audio input, and at the end of the thing, you get back the intent and entities. And we haven't really talked about the entities part of it, but so like, for example, Lex is one of those examples in the Amazon world where I can pay for just the, here's my text string and you tell me the intent that comes back. And that's cheaper than if I say, here's this audio input. I want you to tell me what the text is and also what the intent and entities are for that.
Right.
So that could be more expensive. So there might be reasons like, financial reasons why you might want to do something different with the ASR, but there might be reasons, and there might even be some advantages to having those two steps together, that you go right from the audio input into the intents on the backside.
So two thoughts there. The first is Google has something similar. Their Dialogflow product does much the same thing. You can either feed it in a text input for it to come out with the intent, or you can feed it an audio stream and it will turn that into an intent. The audio stream, though, basically it uses Google's speech to text engine, which you can also get separately. So it's, do you want to do it separately or just have it all bundled together? It's mostly a matter of convenience. But you're right that there are some cases where bundling them helps, and there are some cases where keeping them separate causes problems, I think. And I think we'll touch on some of those problems.
Yeah.
Let's make sure we touch on some of those problems. So let's talk about ASRs a little bit. As I said, I know Google has a product cleverly called Google Cloud Speech to Text. Gotta hand it to those.
There is no ambiguity in what it is, though.
No, this is true, and you gotta hand it to the Google marketers, that the crack Google marketing team, that sometimes they just get the name spot on.
But like Amazon takes the other approach. It's like, oh, this is Lex. What is Lex? Well, it's not quite Alexa, but
and it's not
Alexa. It's just Lex without the A's, I guess.
Interesting. So I think the advantage of being able to do it as part of the separate component means you have a little more control over it. At least I know on the Google Cloud side, you can pick between several models. And on the Dialogflow side, I don't think you can choose which model you want to use. So, if you've got use cases that you're specifically trying to do, you can test them against the various models and see which ones produce better output. And you have to realize these ASR models, some of them are very complicated because they're trying to pick between which various homonyms that can be there.
Right.
So it's the responsibility of these models to kind of pick between the right homonym. So for example, something like, I need an appointment for 4. Is that 2 number 4s that we're talking about? Is, what does that mean? Or sorry, not what does it mean? What does it look like as text? And it's the ASR's job to figure that out.
Yeah, and it's a lot of the times the language models that you're defining doesn't really have anything to do with the ASR. In some cases it does, depending on what you're using, because it's just saying this is the text string, and I'm, these two words together. And it's kind of interesting, like if you're doing something like on Chrome, and Chrome has its own built-in ASR, and you start talking, you can start seeing, and I think you can probably even see the same thing when you're talking to Google. It starts saying the words that you're saying, and then it like groups them together. I'm like,
And then it
oh, I
goes
think you're
back
talking about this, and then you
fixes
say
an old
something
one.
else, and it switches it back to something else, and then
Yeah.
you finally, it's trying to figure out which words go together. It's kind of like like when you're typing something on your phone and it's doing the autocomplete. It's not like, oh, the next best autocomplete for this point in time is this. Oh no, we're changing the autocomplete to this now. So that's kind of ASR, but it's not really the language model that you're doing, because the language model is mostly geared towards, this is for this sentence, these are the intents that map to it. So that's kind of the second side of things. Go ahead.
I would have called that the conversation model.
Yeah, Amazon calls it the language model.
Oh, interesting. Okay.
Yeah.
See, I always think of what the NLU does, the artificial intelligence behind the NLU, as having a conversation model, whereas the artificial intelligence behind the ASR has a language model. It understands whatever the language is that you're speaking. And I think that whole words jumping around type thing, it's a little bit weird, but when you see what some of the output of the ASR is, it kind of makes sense that really what the ASR is doing, it doesn't really give one sentence. It gives a bunch of sentences with the probability of each sentence as it goes.
Yeah.
So, this is my best guess for what I think they said, and this is my second best guess for what I think they said, and here's how confident I am that this is what they said. And usually tools like Google Assistant and Alexa and Dialogflow take the number one response from the ASR.
Yeah.
And just assume that's it, that it got it right. Whereas at the end, that's not always the best approach in some ways.
Yeah, and so that in your terminology, that conversation model that you're saying, these are the intents that I want you to figure out if this is the text that's been said. How that doesn't really influence the ASR. There are some packages that do kind of join those things together. Comes to mind something like a Houndify, or I'm trying to think of other kind of combination engines. It might even be similar, like with Pico Voice. There's lots of different providers that either provide ASR or NLU or both, that they do try to go from that audio input speech right to understanding, as opposed to let's convert that to text and then we feed that text string into the next thing in the pipeline and we figure out what you meant by that.
So one of the other approaches similar to that I've seen are what they are biasing hints. So sometimes I've seen cases where the NLU will say, can tell the ASR, here are words that I am expecting. Here are some entities that I'm expecting, for example. You might want to bias these a little bit more over similar sounding ones that aren't there. So it's not, it never is an absolute, but it kind of nudges it in a different direction. I've seen that on some ASR NLU combinations.
Yeah, because if you're like have a food menu, or you have something that's a very prescribed list of words or phrases that are the main focus of the assistant. That's also why it's important to have a very focused assistant, as opposed to like a general purpose answers everything in the world. Because then that just gets so much harder. But I could see that influencing. So if you said something that was really close to like, oh, this is obviously this menu item, it makes more sense if that, and that's I think what we're going to see more of is being able to have tools where what we specify in that model that was originally just for figuring out intents and entities, start influencing, how the ASR is
Yeah.
like you say, biased, or how that's being processed.
I can easily see more and more biasing like that. And on the flip side, I can also see NLUs getting smarter and saying, instead of just taking the top one ASR hit,
Yeah.
looking at the range of them and saying, well, this one came in second, but not by very far. And it has some of the entity matching, and it's a better fit for some of the phrases that we have. So maybe that's really what they said.
Yeah, and that's interesting too, because then you could do something like, well, these two are really close. It could automatically then come back with did you mean A or B?
Yeah.
Or something like that. And the assistant could take more of that on. This isn't exactly the same thing, but like, for example, with Lex, you could also say, this is kind of like if you have a lot of slot filling that you need to do, you have a specific intent, but you have 4 slots. It's like car reservation, and you need the date and the location and the type of car and I don't know, whatever else. You need all that information before you can do something. That's still a conversation turn to get each of those different slots. And one of the things that Lex allows you to do is that you can define that slot filling logic inside of Lex itself. So that's no longer in your business code, it's in the model. And so what you get back from that ASR or the NLU layer is not just intents and entities, but also conversational response items. And so then you could like forward that off to the response that says, oh, this is the text, because you could even specify these are the texts that you would say.
Okay, I know where you're going with this.
So,
yes.
And that's another feature that some of these things provide.
Right, and that's a feature that Dialogflow has as well. Both of the flavors of Dialogflow. We're going to cover Dialogflow in more detail another time.
Yeah, sure. we definitely need to,
because that's they're the big players, and I need to convince Google that I know what I'm talking about when it comes to some of this stuff. I should remove that from the script. Anyway, so I think I think what we're seeing in general is ASRs are getting a little bit more responsibility, and NLUs are getting a lot more responsibility. And I think combining them together under I already forgot the name of it.
SLU, spoken language understanding. Yeah.
Is certainly an interesting approach, as we see them, overall getting more and more of the fine-grained control that we're going to be needing with independent assistants.
Yeah, and something you also have to consider about is like, is this assistant going to live in mobile? Is it going to live on web? Is it going to live in its own custom hardware? And those different things could mean different things. Like if I know that my browser is going to be Chrome, then Chrome's got a pretty good ASR built into it. So you could save some money and just let Chrome process the ASR piece and send you the text.
You've got me really curious. Is Chrome's ASR actually built into Chrome, or is it just streaming it to Google Cloud? And I don't know.
I don't know. It's not charging anybody anything. No. So,
well, I mean, I know that, for example, Android has a speech-to-text engine, or a speech-to-text framework that has multiple engines in it. Mm-hmm. And I'm sure that on, something like a Pixel 6, that can handle speech-to-text locally, it handles it using a built-in engine. Whereas for ones that don't, it streams it to Google, I'm guessing.
Yeah.
But I'm not sure how much developers have control over that. Yeah, that's on my list of things to dig into more on the Android world. My very long list of things to dig into more on the Android world.
So, but like interesting, like some other browsers, like non-Chrome browsers, then you can open up the mic and you get the stream of audio. So you could get the base 64 encoded audio either as a blob of audio once you're done, or it could be streaming. And so then you would need to have something on the server side that's actually doing the ASR for that. So depending on how you're using that, you might have very similar backend logic, but depending on if the client is, like I say, a smart speaker that you're, custom hardware, or a browser, or mobile, then you might have, in some cases, the processing of the ASR being happening on the client, and some of that might be pushed to the server.
And I think in some ways that's good, because what that means is you can see if you can handle it locally, and you know that the local model will handle it well enough. Use that, great. Or use, if you need to program your own local models that are going to run in JavaScript, use TensorFlow Lite or something like that.
Yeah.
Or send it off to the cloud. Google and Amazon are both, have nearby places for you to hit. They'll get you a streaming response quickly. And it's a lot less effort. Or start with a streaming one, and as your product matures, move it locally to improve performance.
Yep.
That's, as developers, we can evaluate all these options and figure out which one is the best given our current set of criteria.
Yep. And using good old client server, kind of design patterns, you can separate the client side of it from the server business logic side of things, so that you could reuse your business logic across multiple clients. And you don't have to worry about, you have to worry about your client if it's going to do ASR or not, but then a lot of your business logic and, talking to API calls and data storage and all that stuff could just happen on the server.
Right. Well, and actually, so without anything, we wandered all over the topic map here. Was there anything else we wanted to cover on ASRs?
No.
Okay.
Other than with ASR and NLU, each of those steps take time.
Yes. No, that's an
The
excellent point.
longer the phrase that you say, the longer if it's going to take to send that big chunk of information, or to stream that audio up to the server if that's what you're doing. So that takes time, and then actually running it through the NLU step could take time too, especially since a lot of times you're making another API call for the NLU to get the intensity.
Right, and that reminds me of one of the other main features in an ASR, actually in the microphone stage, is the silence detection point. How do we know when the person has stopped talking? And that's kind of outside the ASR component, but it's important to keep in mind as you're developing a system on your own. That you don't want to just keep the mic opening, because now you keep streaming stuff. Somewhere you need to say, they've said enough, or they've stopped, and apply some logic to deal with that.
Well, and then you've got to think about like the other side of the sandwich. If that's one piece of bread, which is the silence detection, there's the wake word detection on the front.
Yep.
And so, or you could do a tap to talk. That's
right.
that's a paradigm too. But if you've got a wake word, you've got you're listening for that
Constantly.
wake word, which triggers, and then that has to trigger the start of the actual recording of the part that's the utterance that you want to say to the silence detection point, to know that that's the audio chunk that's going to be converted into the through the NLU.
And that's a really good point. And that's that wake word detection. I mean, there's a number of important features about it. One of which is that it really needs to be handled locally. You can't handle that remotely.
Yeah.
I don't think any of the systems ever tried to handle it remotely, because it's not a good approach.
Right.
But that means you're limited to certain words and certain words of characteristics of words.
Yep.
And that's why, there's always I'd love a custom wake word. Yeah, a custom wake word would be great, but that's a lot harder than it sounds.
Yeah, and in most cases, you've got like on a device, you've got one wake word that it listens for. And so, because on Amazon, you can select computer or you can select Ziggy or Echo or, so, but you can only have one of those active at a time. It's not listening for all of those. You have to specify this is the word that I'm wanting to listen for so that it can, very tightly just listen for that one thing and then, process it out afterwards.
And it's interesting. I've talked to some engineers before about the characteristics that go into a wake word. And
Yeah.
it certainly used to be, and maybe it's gotten better, but it certainly used to be that they preferred words, or they preferred trigger phrases that were at least 3 syllables.
Yep. That's still the guidelines that I know of.
Well, except Ziggy doesn't quite meet those criteria. So they're pushing the envelope somewhere.
They are. Yeah, they definitely are with that. But I think with Ziggy is such a and they probably look for like differences in like word, like I don't know. See, I'm not a
I'm
sound
not a
engineer or an ASR engineer. But it's looking for definitely different parts of different like sounds and how those vary from other parts in the syllable. If you had something that was a very monotone word, then that probably would be a great
that was a good point. So
wake word.
I think we covered ASRs.
Yeah.
On the NLU side, I mean, there's a whole wealth of things that need to be done and need to be handled when it comes to NLUs. Things like dialogue flow are, fairly traditional. It's you give it a whole bunch of phrases and it applies a little bit of AI to say, well, if you said something near any of these phrases, we can handle it.
Yeah.
And you give it a bunch of slots and the entity types that go into those slots, and it tries to match and it tries to pick other words, but it's very fuzzy and it more problematic. I mean, it's amazing that it works at all sometimes, I think.
Yeah, sometimes, but and there's other strategies too. So for example, with Alexa, all of the intents are live all the time. So
Which
and
we've talked about.
That could be disconcerting at times because you're frustrated. You're like, I don't really want this. This doesn't even apply in this situation. And so it gets harder. Whereas things like dialogue flow and actions on Google. Does actions on Google allow you to do context as well and say these are the specific intents that I want to be live at this point in time?
Yes, the action builder was actually very similar to Dialogflow CX, which is the new version of Dialogflow. And in it you would have these either pages or scenes, depending on which platform you're talking about, and then which are essentially state machines. Yeah. So you would say, when we're in a particular state, these are the phrases that are valid. These are the phrases that are always valid. These are global intents. And also, these are the slots that I want to fill in, the types that go into those slots. So at any given moment, it can narrow down to at least some extent, sometimes, what you may be trying to say to reduce to reduce confusion.
Right.
Whereas Alexa doesn't have that.
It doesn't have that. And a tool like Jovo allows you to say within this context of this state that I've defined, or in the new Jovo 4, inside of this component, these are the things that I'm expecting. And if it's not one of these things that I'm expecting, then call it unhandled. And then you can, which is different than a fallback. So like unhandled is like, this exists, it's just not pertinent at this point in time of the conversation. And so treat it as unhandled. And then you could, like, if inside that context you're trying to ask a question, you could reroute back to the question and ask the question again, because you said something, as opposed to if you said something like fuzzy pizza unicorns or something, which hopefully you have nothing in your model that would map to that. Then then that would be a fallback situation. Is like, you said something that makes no sense whatsoever. Nothing in any context would understand what you just said in this. And so then you could treat that differently. But interestingly, part of the built-in dialogue management stuff that Alexa has, it does, if you're in the context of handling this dialogue management in a very specific way, then you do have context of what's active during that time, which is
Interesting.
is weird. But yeah, just different strategies depending on which platform you're working on. But
right. And it sounds like Alexa Conversations also has more of a notion of state and what makes sense in each state, where you are in each state. That would be an interesting comparison, actually, to compare how Alexa Conversations versus Dialogflow tackled the problem.
Yeah, it would be interesting to kind of know behind the scenes how that's all working. And
another show.
And yeah, some show in the future.
So, but I think the biggest problem when dealing with, the Alexa model, and certainly something like Dialogflow, is the fact that you've got this disconnect between the ASR and the NLU.
Yeah.
So there are plenty of times where just words don't match correctly, or you have one problem that was raised a number of years back at I/O is they were talking about launching Google Assistant in Hindi, and they said this is, it's great, but you got to be careful because people don't necessarily speak Hindi; they speak Hinglish, which is Hindi with a bunch of English words thrown into it. And if you're writing this out, you would write them as English words. But if you're speaking them, the speech to text system will try to turn that into some Hindi word, which doesn't necessarily, or at least something that vaguely looks like a Hindi word, which doesn't necessarily make sense. And you need to, manually in some cases, figure out, well, okay, this is really an English word, and this is really what it means.
Yeah. Yeah, and there's different situations, and I think this would be, I guess I would clump this into what happens if the output of the ASR, that text string, there are some misunderstandings in it. So it's like if somebody said something to you and you didn't quite understand it, or you heard something and you heard it wrong. There's a clarification step. You're like, what did you say? And then you can kind of get some clarification, but that doesn't, you don't really have that at that.
Right. Or you could say, what did you say? Or your brain can say, well, it sounded like they said this, but really this word makes more sense in context.
Yeah, exactly.
We're better at processing that kind of thing than our systems are.
So this is an invocation phrase, but like if we were to use this inside of a skill, instead of an utterance, if we were to say to voice devs, then we might come up, the first word might be translated as the number 2, or just the word TO, and devs might be changed to debs.
Devs
with a B.
We've never seen that before.
So there might be cases where you're like, if you come up with, TOO voice devs, then really I want 2 voice devs, TWO.
So we want aliasing of some sort.
Yeah. So it's not necessarily synonyms, but it's like string replacement. So there was the conversation that we had on office hours that about, well, what if you had access to that ASR string right before you sent that off to NLU, and you could do some, I guess, pre-processing on the text before it was passed to the NLU. Then what kind of things would you do? And so you could do some string replacement, some just very basic string replacement. If you know that this word two or three words happens and it's a misunderstanding, you
And
could
it's a
correct
consistent
it.
misunderstanding.
Yeah.
Yeah.
Yeah, you don't want to do too much in that layer because then that starts getting into context or personalization, and you're like, that should actually be handled on the other end after you get back with your intent. You can have additional intents, or you can disambiguate based on slots, or there's different things you can do on that end. But that might be a case. There might be a case where you're really heavy in like menu items, like we said, or it could be a system where you have a list of people's names, and it's consistently, if it's like this name and this name, and it's Sean, is it Sean spelled this way, or is it Sean spelled, SEAN? Is it so? If you see this name, you could replace it with the actual name, so that when it gets to the point where it's like looking that up, it actually has the right name. Or it could be location names, or it could be like the case that you said where you're mixing a foreign word in with your main language, and maybe that's a something that you consistently want to do, but you could do that type of quick string replacement right before the NLU processing.
And I think that's an important point, is that it is a quick string replacement, because otherwise it means you need to add these aliases into the NLU training itself. Yeah. And that now becomes a lot of other additional work. So I think anything that can shortcut things a little bit can sometimes really help.
Yeah, and you have that opportunity, whereas like normally your language model for that part is something that you have to like pre-build.
Yeah.
And so
every time you see a difference, you need to rebuild it.
Yeah. Whereas you could have this layer where you've got some sort of content management system where you've specified, oh, let's put this in there, and now it just happens really quickly before, and then like over time you can start decide like, all right, do I want this change here? I've got 100 of these string replacements here. Which one of these should I actually move into the conversational model and have that handled as far as synonyms for my slots or something?
And this actually reminds me of something else, and it's a point you raised earlier, that just each of these components takes time. So going into the NLU itself, that takes time. And sometimes if all you're using the NLU for is to identify an intent, sometimes NLUs can do more, but if all you're using it for is to identify an intent, that can be a pretty expensive operation. And if you're just saying, if the user just says something like, yep, yeah, that's a lot of effort for a really simple phrase. And I understand Jovo is trying something to address that.
Yeah, so they did create a plugin, and you said expensive just a moment ago, and I wanted to kind of tease out that word a little bit. Did you mean expensive as in time consuming, adding to the overall response time, or expensive as in cost you real dollars because you're paying a service to do it for you?
Well, in this case, I meant expensive in terms of time, but since Dialogflow charges for each call, that's also expensive in terms of money, or over time anyway. Yeah,
over time. Yeah, they're in some cases, like NLUs are typically a lot cheaper. They're like pennies for the or fraction of pennies for the translation of it, and so you have to have a lot of throughput to actually have it cost quite a bit if you're doing NLU. Whereas if you're having the system, the backend system, do the ASR part, that could be very expensive. That could be hundreds of dollars a month for that point. So, but no, I agree with you, and that it really depends. And what we were talking about specifically was that it takes extra time. But kind of to handle this thing, Jovo came out with just a plugin that does exactly some of the things that we talked about. Is that it originally it's like a preprocessor for the NLU step, whereas it will first check to see if what you said matches a small list of words or phrases, and if it does, then it will say just use this intent. And so that's really quick. That's no API call at all. There's no cost in time or or money to use an API service. And in some cases, like if you're doing, why do I always forget that? On Google, when you have little dialogue buttons that have single words at the end of a response,
Suggestion chips.
Suggestion chips. I was like, oh my gosh, this should be like a game. Like name that
feature.
Yeah, suggestion chips. So like if you have just something short with the suggestion chip, it could be a yes, it could be a no. Then you can just handle that really quickly. And if it doesn't match that list, then it could send the rest of everything back to NLU. So I thought that was probably an ingenious approach to handle some cases that I've had before. It's definitely a plugin that I would use.
It's a clever plugin, but I think there's caveats here.
Yeah.
And the first is it doesn't work with Alexa, because Alexa, you're not before the NLU.
No. So the input, the request that's coming in from Alexa already tells you what the intent and slots are.
Right.
That's it. That's it completely handles the ASR and NLU for you. You just get the output of the NLU as the request that you get. But if you're doing a chat bot, if you're doing a custom assistant that's mobile or web, trying to think of where else.
Well, I think the big thing is in custom assistants, where you may have an ASR in place, where you may be using Raza or something like that. That this is now a place where you can handle things a little bit faster. I think the other caution, though, is you don't want to rely on this too much.
Yeah.
Because all it is string matching.
Yeah.
It's great for a chatbot where you can make sure they type exactly that. But if you're expecting people to have something of a more natural conversation, you're going to end up putting in thousands of strings in here to try to match everything that a person could say. And that's just a terrible approach.
Yeah. And if I can imagine this, I don't know, since my depth in creating voice assistants is basically 6 years old or whatever, right? That I imagine going back 10, 15, 20 years, maybe that was the approach that they took. That's kind of how they started. And then they started figuring out that you can train language models and things like that.
The impression I actually had is that the very first Alexa model, you needed to list in a bunch of phrases. And those weren't training phrases. Those were exact matches.
Really? I that's the first I've heard of that.
Now that's what I remember, and maybe my memory is faulty, and maybe somebody from Amazon will correct me on that. But what I remember was those were exact matches. They weren't training phrases. Nowadays we give it training phrases and the AI fudges it on its own. But back then it was exact matching, exact pattern matching, because you could indicate where a slot was.
Yeah. So yeah, and it's also interesting on NLU is that in some cases you can say this is a finite list, this is a closed list, so only deal with the slots or entities
that exactly
that I'm giving you.
Yeah.
Other ones are like, oh, you gave me about 30 different examples. Some of them are 1 word, some of them are 2 words, some of them are 3 words. All right, you said something else that doesn't match anything that's in that list, but it's 3 words. The rest of the anchor phrase matches. I think it's the same thing. Here you go. Which might be perfectly great.
It might be what you want. I mean,
that might be exactly what you want. So,
right, certainly when you're dealing with things like names, there's no way you're going to try to list every possible first name.
Right. Yeah.
But you want something that kind of seems like it might be a first name, whatever that means.
Yeah. So back to the Jovo plugin. What is it called? It is called the Keyword NLU. And so if you go to the Jovo Marketplace, you can see that. You can look at the code and kind of see. You can even just see the README page and get a good understanding of what it does. You get to provide a list based on locales, just like the country portion of the locale. So like EN for English, DE for German. And then you can list a list of key value pairs so that it will look to see what if it finds that key. And if it does, it's going to use the intent, that's the value, and just short circuit the NLU process. Something that I worked on a little bit today was adding in that string replacement piece as kind of like a precursor step to even that step, where you can say, here's a list of, key value pairs. If it finds this key in there, do a string replacement in the input text with the value as many times as it is in the string, and just do, go through every item in the list and do string replacements. And at the very end, now you have a new text string that's passed on to that next step. And if it's not handled in that next step, then it's passed off to the NLU. I don't know, it'll be kind of interesting. But once again, it has some uses.
Yeah.
But you have to kind of at some point decide, if I've got 1,000 or 2,000 of these string replacements happening, that may still be very fast. I don't know. You'd have to like.
I think we're talking memory, so it's probably pretty fast these days. But I do think it starts getting unmanageable, and I think at some point this is where, as developers, we need to say, okay, when is this a tool, and when are we abusing a feature?
Yeah.
When are we torturing a feature to get what we want out of it? When it should be done a better way. And as always, as developers, that's part of what we're out to figure out. That's part of our job.
Yeah, and I could see like in the future, ASR systems progressing where you could provide a data dictionary to the ASR of those types of string replacements that you would like to see happen, and that just happens on the server side of things. So I think things like that. I also think that sometimes it's challenging to say, okay, this word or these words have to match, and it's a English, and whatever the language is, but in this case, an English string comparison, whereas there is IPA, and you can define how words sound with IPA.
That's actually an excellent.
Wouldn't be great if you could then provide like, if I have this word and or words that sound like this word defined in IPA, then this is the word that it actually should be, understood as.
That's an excellent point. We really hear very, very little about IPA specification on input, whereas we talk about it all the time on output, even if we forgot to mention it last week. We've talked about it before, though. We
have talked about it before. The last piece that I want to bring up, and this is kind of just for completeness sake, because we were talking about the ASR and the audio input side of things, there is still the whole, how noisy is your environment?
Yes.
Or like how much, I guess, how good is the audio? So like audio talking on a phone is different than, audio, or like even talking on like an old dial-up phone compared to a smartphone.
And I would add to that also just dealing with accents. It amazes me sometimes that all of the ASR systems are bad at it, but it's amazing how good they are. As bad as they are, it still amazes me sometimes that they work as well as they do sometimes.
Yeah. And said slightly a different way is there is still room for improvement.
There's a lot of room for improvement
on ASR, on even just getting clear audio input for noisy situations. Like if you're in a car mechanic garage and you're talking, there's echo and there's noise and there's tools and there's different things going on. That's challenging. So kind of like the audio processing before it even gets into the ASR is another area where improvements can be made.
Definitely. So we've covered ASR, we've covered NLU, we've covered
a whole bunch of other things.
Bunch of other things related to all parts of these. Anything else we wanted to cover tonight?
No, but that's good. I like that because in the end, we're really talking about the whole front part of of assistance, the audio to the text, the thing that finally gets to the business logic part, and then last time we talked about the text to speech, which is the output response side of things. So it's kind of a nice
Right.
to group those up into like those three
Rounds
main
it out well.
areas.
And
Yeah,
I think also, yes, as people who are developing skills or people who are developing audio apps, we really don't need to get into the nitty-gritty of this a lot of the time, but it's really useful to understand, at least on a high level, how some of it works, so that
yeah,
we know as we're doing conversation design, this is why we need to pay attention to things in this case. Or if our system lets us do things like suggested keywords or keyword hinting, when would we want to take advantage of that, and why would we, and what does it do? So we don't usually get into the guts of these systems. We'll try to find a guest who can talk about the guts of these systems sometime, but I think it's important for us to at least have a basic understanding of it.
yeah. And one of the things, this is just kind of for interest on people that are wanting to make a career of this. One of the questions that I ask when I'm interviewing people is just explain from the user talking to the microphone to what's the process, the request response process, what are the steps that it goes through, and kind of what happens in each of those steps. I don't expect you to be an expert. I'm not an expert in each of those areas, but it is important to know what the pipeline is, what happens, this leads to this leads to this, and understand kind of how that all fits together, because that's an important end-to-end part of just understanding how voice assistants work.
Definitely. So we'd love to hear others' thoughts on this. As always, you can leave comments below or find us on social media, where we'd love to talk to you about this or many other topics.
And we're going to keep plugging this as time approaches. We're in September. Next month is October, and Alan and I will be at Voice Summit live and in person. You can listen to us do a Two Voice Devs broadcast there, or the other talks that we're doing, or just talk to us in the hall, or
Yep.
Meet us for dinner or something.
And at Two Voice Devs Live, we will be taking audience questions. So
Yes.
we'll be having more information on that. If you're in the hall, we'd love to hear from you there. If not, we will be taking questions ahead of time to make sure that we answer them then. So Two Voice Devs live and in person at Voice Summit in October with your questions.
That would be great. I'm really looking forward to it.
I'm so looking forward to this. This is going to be fun. So until then, we will see you another time on Two Voice Devs.
Two Voice Devs. Take care.
Take care. Have a great week.
Thank you.